Imagine you are standing at the edge of a vast digital frontier, a landscape where the boundaries between human capability and artificial intelligence blur into a haze of unlimited potential. Behind you lies the familiar territory of traditional problem-solving, manual research, hours of writing, and the slow crawl of independent thought. Ahead stretches an unexplored realm where tasks that once consumed days can be completed in minutes, where creative barriers dissolve, and where the constraints of individual knowledge expand to encompass the collective wisdom of humanity. This is not science fiction. This transformation is happening right now, silently revolutionizing how millions work, learn, create, and solve problems. Yet most people using tools like ChatGPT are merely scratching the surface, typing basic questions and receiving basic answers, unaware that beneath this simple interface lies a cognitive superpower waiting to be unleashed. Dr. Hannah Jennings, a computational linguist at MIT, puts it bluntly: the gap between average users and power users of AI language models isn't just wide, it's dimensional. It's the difference between using a smartphone only to make calls versus leveraging its full capabilities to transform your entire life. What if I told you there are specific techniques, veritable cheat codes for reality, that can multiply the effectiveness of your AI interactions tenfold? Methods so powerful that using them feels almost unfair, as though you have discovered a shortcut through the traditional constraints of human productivity and creativity? Today, we journey beyond the basics into the realm of AI language model mastery, exploring 23 techniques that push ChatGPT to its limits, methods that will fundamentally alter how you perceive the boundaries of what is possible. To understand the revolutionary potential of these techniques, we must first grasp how we arrived at this extraordinary moment in human-AI interaction. The path to today's large language models began decades ago, winding through linguistic theories, computational breakthroughs, and exponential advances in data processing. In 1950, Alan Turing published his seminal paper, Computing Machinery and Intelligence, introducing what would become known as the Turing test, a benchmark for determining if a machine could exhibit intelligent behavior indistinguishable from a human's. For the next half-century, this remained largely theoretical as early natural language processing systems struggled with even basic interactions. Dr. Walter Klein, who pioneered early statistical language models in the 1990s, recalls the limitations. Our systems could recognize patterns, but they couldn't understand context or generate meaningful text. They were essentially sophisticated pattern-matching machines, not thinking entities. The first breakthrough came in 2013 with the development of word embeddings, mathematical techniques that represent words as vectors in multidimensional space, allowing algorithms to capture semantic relationships between concepts. Words with similar meanings clustered together in this mathematical space, enabling models to make primitive semantic connections. But the true revolution began in 2017 with the introduction of the transformer architecture, which allowed models to process language with unprecedented attention to context. Unlike previous systems that process text sequentially, transformers could consider the entire context simultaneously, weighing the relevance of each word against all others. It was like suddenly giving a nearsighted person perfect vision, explains Dr. Jennings. Previous models could only see a few words ahead and behind. Transformers could take in the entire landscape of meaning at once. This architectural innovation led directly to GPT, generative pre-trained transformer models, trained on increasingly vast datasets of human-written text. Each iteration grew exponentially in size and capability. GPT-3 trained on approximately 570 gigabytes of text, encompassing books, articles, websites, and social media posts. Its successor expanded this knowledge base even further. But here lies the fascinating paradox that frames our exploration. Despite the sophistication of these models, most users interact with them in the most rudimentary ways. A 2023 Stanford study revealed that 82% of ChatGPT users employ only basic prompting techniques, essentially treating the AI as a slightly more advanced search engine. It's like being given a Formula One racing car but driving it like a golf cart, notes technology researcher Harper Jacobs. The average user is experiencing perhaps 5% of what these models are capable of. This brings us to the central question that will guide our journey. What techniques separate novice users from those who can extract truly remarkable, seemingly unfair advantages from these same tools? How can we transcend basic prompting to leverage the full capabilities of this technology? The answer lies in understanding that ChatGPT is neither a search engine nor a simple question-answering system. It is a context processing engine of unprecedented power, one that can be precisely guided, constrained, expanded, and directed through specific prompting strategies that most users have never considered. As we venture into these techniques, you may wonder, is this ethical? Are we cheating by using AI to extend our capabilities so dramatically? Professor Wendy Kelsey, a digital ethics researcher at Stanford, offers perspective. These tools do not replace human cognition, they extend it. The ethical question isn't whether using them constitutes cheating, but rather how we incorporate them into our work with transparency and purpose. With this framework established, let us now dive into the mysteries of advanced prompting, the hidden techniques that transform ChatGPT from a useful assistant into what can only be described as a cognitive superpower. The first technique that separates power users from novices is what experts call the expertise persona framework, a method that transcends simple prompting by reconfiguring the AI's entire approach to your request. Instead of asking ChatGPT a direct question like, "How do I create a marketing strategy?" average users receive general, somewhat generic responses. But watch what happens when we restructure the interaction. You are an award-winning chief marketing officer with 25 years of experience in direct-to-consumer brands. Walk me through creating a comprehensive marketing strategy as if you were mentoring a promising junior executive. The transformation in response quality is immediate and profound. The AI shifts from providing generalized information to adopting the specialized knowledge patterns, terminological precision, and strategic thought processes associated with genuine expertise in that domain. What we're doing is manipulating the model's statistical weightings toward a specific subset of its training data, explains Dr. Jennings. By invoking a specific expertise persona, we're effectively telling it which patterns of language and thought to prioritize. This goes far beyond role-playing. In a controlled experiment at Carnegie Mellon University in 2023, researchers found that expertise persona prompts improved the accuracy and specificity of technical responses by 42% compared to direct questioning. The applications are staggering. Need legal analysis? Engage a constitutional law professor persona. Wrestling with coding problems? Summon a senior software architect with specific language expertise. Struggling with a philosophical question? Call forth an Oxford don specializing in epistemology. Harold Jackson, a freelance consultant who uses this technique daily, shares his experience. I once had 48 hours to prepare a comprehensive analysis of the semiconductor supply chain for a client presentation. By engaging ChatGPT with a semiconductor industry analyst persona and building on its responses, I delivered an analysis that the client later told me matched what they'd previously received from a consulting firm that charged them $45,000. But this technique reveals a deeper truth about large language models. They contain multitudes of implicit expertise, accessible only if you know how to summon it. While the persona framework reshapes who the AI is, our second technique, chain of thought scaffolding, transforms how it thinks, producing results that seem almost magically enhanced. Average users accept the AI's first response as its best offering. Power users understand that AI, like human thinking, can be guided through progressive reasoning steps to arrive at superior outcomes. Consider this example. Rather than asking, "What are the best investments for retirement?" a power user might prompt, "Let's think step by step about optimal retirement investing." First, identify the key factors that affect retirement investment choices. Second, analyze how these factors change at different life stages. Third, evaluate various investment vehicles against these criteria. Fourth, develop a decision framework for optimizing retirement portfolios based on individual circumstances. This structured approach forces the model to decompose complex problems into manageable components and reason through them sequentially, mimicking how expert human thinkers approach difficult questions. We've discovered that language models contain latent reasoning capabilities that remain dormant unless explicitly activated, explains Dr. Martin Hewitt, an AI researcher at DeepMind. Chain of thought prompting essentially awakens these capabilities. The scientific evidence is compelling. In a 2022 paper published in Nature Computational Science, researchers demonstrated that chain-of-thought prompting improved accuracy on complex mathematical word problems by 91% compared to direct questioning. What makes this technique particularly powerful is its ability to overcome what AI researchers call hallucination, the tendency of language models to generate plausible-sounding but incorrect information. By forcing the model to show its reasoning, errors become more apparent and can be corrected midstream. It's like the difference between asking someone for an answer versus asking them to think aloud as they solve a problem, notes Dr. Jennings. The latter approach not only yields better results, but also provides insight into the process itself. Building on chain-of-thought reasoning, the third technique, feedback loop iteration, transforms a single interaction into an evolving dialogue that progressively refines outputs to extraordinary levels of quality. Average users accept whatever response the AI generates initially. Power users understand that the first output is merely a starting point in an iterative process of refinement. The technique works like this. After receiving an initial response, you provide specific feedback about strengths and weaknesses, then request an improved version. This creates a rapid evolution of the output that quickly approaches, and sometimes exceeds, professional quality. Write a sales email for our new software product might yield a decent first draft. But the power user continues. The email is too general. Revise it to emphasize our unique security features, use more specific statistics from our case studies, and create more urgency in the call to action. This feedback loop can continue through multiple iterations, each refining different aspects of the response. Wendy Kearns, a content strategist who uses this technique daily, reports, "I've run experiments where I took my own professionally written copy and ran a parallel process using ChatGPT with feedback iteration. By the third or fourth iteration, blind reviewers consistently rated the AI-generated content higher than my original work, even though I was the one guiding the AI's refinement process." The science behind this technique reveals something profound about language models. Research from Google Brain shows that these systems possess what they call latent knowledge, information and capabilities that exist within the model but remain inaccessible unless specifically evoked through the right prompting techniques. It's as though parts of the model's knowledge are in a dormant state, explains Dr. Hewitt. Iterative feedback activates these dormant capabilities, essentially waking up different parts of the model's knowledge base. This technique fundamentally changes the human-AI relationship from a transactional question-and-answer format to a collaborative creation process, one where the human provides creative direction and critical evaluation, while the AI handles execution and iteration. Our fourth technique, constraint optimization, counterintuitively achieves better results by imposing specific limitations on the AI's responses. Average users make vague, open-ended requests that produce generic outputs. Power users understand that creativity and precision often emerge from thoughtfully applied constraints. For instance, rather than asking, "Give me ideas for my business blog," a skilled practitioner might request, "Generate 5 business blog post ideas that 1. Each incorporate a surprising statistical insight, 2. Challenge a common industry assumption, 3. Can be explained in under 1,000 words, 4. Include a specific actionable framework, and 5. Would be uniquely valuable to mid-career finance professionals." The specificity of these constraints forces the model to generate far more targeted, original, and valuable outputs. This technique works because it navigates the AI away from statistical averages, what the model sees as the safest response, toward more precise and creative territory. By specifying constraints, you essentially redirect the model's attention to a narrower but deeper subset of its knowledge. Language models naturally gravitate toward producing what I call statistically average responses, explains Dr. Jennings. These are responses that reflect the central tendencies in their training data. Constraints push the model away from these central tendencies and toward more specific regions of its knowledge. The experimental evidence is striking. In a study conducted at Stanford's Human-Centered AI Lab, researchers found that applying 3 or more specific constraints to creative tasks increased the originality ratings of AI-generated content by 74% compared to unconstrained prompts. Howard Jameson, a fiction writer who uses this technique for creative inspiration, shares, When I ask for general story ideas, I get predictable plots that feel recycled. But when I specify a mystery set in 1920s Shanghai involving a missing astronomical device, a character who cannot remember Tuesday, and themes examining the nature of time, suddenly I get fascinating and original material I can actually use. This technique reveals something profound about creativity itself, that it often thrives within boundaries rather than in unlimited freedom, a principle that applies to both human and artificial intelligence. The fifth technique, perspective contrasting, leverages the model's ability to simulate different viewpoints to generate remarkably balanced and nuanced analysis. Instead of asking for a single perspective on a topic, power users prompt the AI to generate multiple contrasting viewpoints, resulting in a comprehensive understanding that transcends individual biases. For example, rather than asking, "Is remote work better than office work?" a skilled user might prompt, "Analyze the remote work versus office work debate from 5 perspectives. 1. A company focused on innovation and collaboration. 2. An employee with young children. 3. A commercial real estate investor. 4. A climate scientist concerned about carbon emissions. And 5. A city urban planner." For each perspective, provide their likely position, supporting evidence, and primary concerns. This approach transforms simple questions into multidimensional analyses that reveal nuances and trade-offs invisible from any single viewpoint. What makes this technique powerful is that it activates different regions of the model's training data simultaneously, explains Dr. Raymond Chin, an AI researcher at Berkeley. Instead of producing a response that averages out these perspectives, it keeps them distinct, preserving their unique insights and concerns. The applications extend far beyond simple debates. Financial analysts use perspective contrasting to evaluate investment opportunities from different stakeholders' viewpoints. Product designers employ it to anticipate how various user types might interact with a new feature. Policymakers utilize it to understand how proposed regulations would affect different community segments. It's essentially a form of automated red teaming, notes Dr. Jennings. It forces consideration of viewpoints you might otherwise overlook or undervalue. The psychological effect on users is equally significant. Research from Harvard Business School found that decision-makers who used perspective contrasting reported 37% higher confidence in their final decisions and demonstrated greater awareness of potential unintended consequences. Our sixth technique, metaphor expansion engineering, taps into the model's ability to translate complex concepts between domains, creating powerful explanatory frameworks that make difficult ideas accessible. Rather than asking the AI to explain a concept directly, power users request that it develop and elaborate on specific metaphors that make abstract ideas concrete and memorable. For instance, instead of "explain how blockchain works," a skilled practitioner might prompt, "Develop a detailed metaphor that compares blockchain technology to a physical system or everyday process." Extend the metaphor to explain 1. Distributed ledgers. 2. Mining and consensus mechanisms. 3. Smart contracts. 4. The immutability of records. And 5. How security is maintained. Make sure each aspect of the metaphor accurately reflects the corresponding technical concept. The results can transform comprehension of complex topics. A blockchain might become a community library where everyone keeps identical copies of all books, with new editions requiring community verification before everyone updates their collection, and special books, smart contracts, that automatically update other books when certain conditions are met. Metaphors are not merely explanatory tools. They're cognitive frameworks that shape how we think about concepts, explains Dr. Wendy Kaminsky, a cognitive linguist. What this technique does is harness the language model's cross-domain mapping capabilities to create conceptual bridges between the familiar and unfamiliar. The scientific basis for this approach lies in cognitive science research showing that human understanding of abstract concepts is fundamentally metaphorical. By deliberately engineering extended metaphors, we leverage this aspect of cognition to accelerate comprehension and retention. Education researcher Helen Jacoby conducted a study with 400 undergraduate students learning quantum computing concepts. Those who received explanations through engineered metaphors showed 67% better concept retention after 4 weeks compared to those who studied technical explanations alone. What's fascinating is that the right metaphor doesn't just make something easier to understand. It actually reshapes your mental model of the concept, notes Dr. Jennings. This technique isn't about simplification. It's about reconfiguring abstract ideas into forms our minds can more readily grasp and manipulate. Our seventh technique, the Synthetic Subject Matter Experts Panel, creates a simulated roundtable of diverse experts who collectively analyze a problem from different disciplinary perspectives. Instead of interacting with a single AI persona, power users orchestrate a virtual conversation between multiple specialized experts, each contributing unique insights from their field. For example, rather than asking, "How should I invest my money?" a skilled user might prompt, "Simulate a financial planning roundtable with the following participants discussing investment strategies for a 35-year-old professional with $100,000 to invest." 1. A certified financial planner specializing in tax efficiency. 2. A behavioral economist focused on cognitive biases in investing. 3. A retirement specialist concerned with long-term security. 4. A real estate investment expert. And 5. A technology venture capitalist. Have each expert present their recommendations, respond to others' suggestions, and work toward a synthesized approach. This technique transcends individual expert personas by creating dynamic interactions between different knowledge domains, often yielding insights that no single perspective would generate. What we're doing here is simulating intellectual cross-pollination, explains Dr. Hewitt. Some of the most important breakthroughs in human knowledge have come from the intersection of disciplines. This technique recreates that fertile ground for insight. The structure of this technique mirrors what cognitive scientists call distributed expertise, the idea that complex problems require multiple types of specialized knowledge working in concert. By simulating this distribution, users can access a breadth of perspective that would be impractical or impossible to assemble in reality. Howard Jeffries, an environmental policy consultant, shares how this technique transformed his work. "I was developing recommendations for urban water conservation. By creating a panel with a hydrologist, behavioral psychologist, urban planner, economic policy expert, and community organizer, I identified intervention points that weren't visible from any single disciplinary lens." The resulting policy brief was described by the municipal client as the most comprehensive analysis they'd ever received. Research from MIT's Collective Intelligence Laboratory suggests that diverse synthetic expert panels consistently outperform both individual experts and homogeneous expert groups in problem-solving scenarios, particularly for complex, multifaceted challenges. As we delve deeper into these advanced techniques, a profound realization begins to emerge, one that fundamentally reshapes our understanding of what artificial intelligence means for human cognition and creativity. The true power of these 23 techniques lies not in what they allow the AI to do, but in how they transform the relationship between human and machine intelligence. Consider Technique 8, Cognitive Scaffold Construction. This approach uses the AI not merely to provide information but to build extensible frameworks that organize and structure knowledge. Instead of asking the AI for facts about a topic, power users prompt it to create comprehensive knowledge architectures that can be expanded, modified, and personalized. For example, create a comprehensive cognitive scaffold for understanding modern monetary theory. Structure it as a hierarchical framework with foundational concepts at the base, intermediate principles in the middle, and advanced applications at the top. For each concept, include a clear definition, historical context, key debates, practical implications, and connections to other concepts in the framework. The result is not just information but a dynamic learning structure that evolves as the user's understanding deepens. This technique transforms how we acquire and organize knowledge, explains Dr. Jennings. Instead of encountering information as disconnected facts, we receive it as coherent systems that mirror how expert understanding is actually structured. This accelerates the journey from novice to proficient in any domain. Education researcher Dr. Helen Jacobs conducted a study with 300 undergraduate students learning about systems biology, a notoriously complex subject. Students who used cognitive scaffolds generated by AI showed a 78% improvement in conceptual understanding compared to traditional study methods after just 3 weeks. But the implications go far beyond education. This technique reveals that the most powerful use of AI is not as a substitute for human thinking but as an extension of it, a tool that augments our natural cognitive abilities by providing structures that our minds can build upon and within. Technique 9. Socratic dialogue generation takes this partnership in another direction by transforming the AI from an answer provider into a question asker, guiding users through their own discovery process. Rather than asking ChatGPT to solve a problem directly, the user instructs it to engage in a Socratic dialogue, asking probing questions that lead the user to deeper insights and realizations through their own reasoning. I've used this when wrestling with complex business decisions, shares entrepreneur Whitney Keener. Instead of asking the AI what I should do, I prompt it to ask me a series of increasingly refined questions about the situation. Through answering these questions, I often discover that I already knew the answer. I just needed the right questions to unlock my own understanding. This technique inverts the typical human-AI relationship. Instead of the human questioning and the AI answering, the AI questions and the human develops answers, with each response informing the next question in a virtuous cycle of deepening insight. Research from Stanford's Learning Lab found that students who engaged with AI-generated Socratic dialogues showed 42% better problem-solving abilities on novel tasks compared to those who simply read explanations of similar concepts. More significantly, they reported higher confidence in their ability to tackle unfamiliar problems independently. What we're seeing is a shift from AI as an oracle to AI as a catalyst for human thought, explains Dr. Raymond Chin. The most powerful applications may not be those where AI thinks for us, but where it helps us think better ourselves. This brings us to Technique 10, Intellectual Sparring Partner, where users deliberately engage the AI in constructive argument to strengthen their thinking and uncover blind spots in their reasoning. Unlike seeking confirmation of existing beliefs, this technique involves explicitly instructing the AI to challenge the user's assumptions, identify logical weaknesses, and present counter-evidence to their positions, creating a form of intellectual resistance training that strengthens critical thinking. I've used this technique to prepare for board presentations, shares corporate strategist Howard Jenkins. I outline my proposal and then instruct ChatGPT to take the role of a skeptical board member, challenging every aspect of my plan. It's identified gaps in my thinking that would have been embarrassing to discover during the actual presentation. The scientific basis for this approach comes from studies of argumentative theory showing that exposure to opposing viewpoints significantly improves reasoning quality, even when those opposing views don't ultimately change the original position. The resistance itself strengthens the intellectual muscle. Techniques 11 through 15 further transform how we use AI, moving from isolated tasks to integrated workflows that combine multiple approaches. Technique 11. Recursive learning loops uses outputs from one AI interaction as inputs for the next, creating a progressive chain of insight that builds upon itself with each iteration. Unlike simple feedback loops, recursive learning creates branching paths of inquiry that can be explored in parallel and then synthesized. Technique 12. Threshold knowledge mapping identifies precisely what knowledge the user needs to access higher-level understanding in a field. Rather than providing comprehensive information about a topic, it identifies the specific concepts, terms, and principles that function as gateways to more advanced comprehension. Technique 13. Multidimensional framework generation creates custom analytical lenses for complex problems. Instead of applying existing frameworks, users prompt the AI to generate novel analytical structures tailored to the specific characteristics of the problem at hand. Technique 14. Meta-analysis synthesis aggregates and synthesizes multiple perspectives, studies, or arguments into cohesive insights that transcend any individual source. This technique transforms the AI from a knowledge provider into a knowledge integrator. Technique 15. Calibrated counterfactual exploration uses the AI to systematically explore alternative scenarios based on changed variables, allowing users to test assumptions and identify key factors in complex situations. What emerges from these techniques is a profound shift in how we conceive of artificial intelligence and its relationship to human cognition. Rather than a tool that replaces human thinking or a simple assistant that responds to queries, these advanced techniques reveal AI as a cognitive partner, an entity that extends, amplifies, and complements human intelligence in ways that transform both what we can know and how we come to know it. We're witnessing the emergence of what I call complementary cognition, explains Dr. Jennings. It's a form of intelligence that exists neither solely in the human nor solely in the machine, but in the interaction between them. Each brings different strengths to the partnership, and the resulting capability exceeds what either could achieve alone. This complementary cognition manifests most powerfully in Techniques 16 through 20. Technique 16. Dynamic conceptual blending instructs the AI to combine seemingly unrelated domains or concepts to generate novel insights and applications. Unlike simple analogies, conceptual blending creates new conceptual spaces with emergent properties not present in either original domain. Technique 17. Strategic limitation imposition deliberately constrains the AI in specific ways to force creativity and unconventional thinking, similar to how artistic constraints often yield more creative results than complete freedom. Technique 18. Controlled convergent and divergent thinking alternation guides the AI through alternating phases of expansive ideation and focused refinement, mirroring the creative processes of successful human innovators. Technique 19. Nested expertise hierarchies creates chains of specialized AI personas that review and refine each other's work in sequence, similar to how a document might pass through multiple departments in an organization. Technique 20. Temporal perspective shifting prompts the AI to analyze problems from different time horizons, immediate, near-term, and long-term, revealing different priorities and considerations at each scale. These techniques collectively represent a new paradigm in human-AI interaction, one where the boundary between human and artificial intelligence becomes less a barrier and more an interface of collaborative creation. What we're really talking about is cognitive symbiosis, says Dr. Hewitt. These techniques don't just help us use AI more effectively. They help us think more effectively by extending our cognitive capabilities beyond their natural limits. This brings us to our final 3 techniques, which perhaps most dramatically illustrate how advanced prompting transforms ChatGPT from a useful tool into something that feels almost like a cognitive superpower. Technique 21. Comprehensive decision support architecture creates a complete decision-making environment that combines multiple analytical frameworks, stakeholder perspectives, risk assessments, ethical considerations, and implementation planning into a unified system. Technique 22. Synthetic experience generation uses the AI to simulate specific scenarios in rich detail, allowing users to experience situations, conversations, or environments they haven't personally encountered, expanding their perspective and preparatory understanding. Technique 23. Intellectual compound interest leverages consistent documentation and iteration of AI interactions over time, creating a personalized knowledge repository that grows exponentially in value as connections between separate interactions emerge and strengthen. The cumulative effect of these techniques represents nothing less than a transformation in the landscape of human knowledge work. Tasks that once required teams of specialists can now be approached by individuals with the right prompting strategies. Creative processes that typically span weeks can unfold in hours. Learning curves that demanded years can be navigated in months. We're observing a fundamental shift in the cognitive economy, notes Dr. Wendy Kearns. The limiting factor is no longer access to information or even expertise. It's the ability to orchestrate these advanced interactions between human and artificial intelligence. Those who master these techniques gain capabilities that appear almost supernatural to those who haven't. This realization brings us to the central insight emerging from our exploration. The true revolution is not in the AI itself, but in the novel cognitive capabilities that emerge when human and artificial intelligence are skillfully combined through advanced prompting techniques. As we assimilate the extraordinary capabilities enabled by these 23 techniques, we must confront their profound implications, not just for individual productivity and creativity, but for education, professional expertise, organizational structures, and even our understanding of human cognition itself. First, these techniques fundamentally reshape the landscape of knowledge work. The traditional progression from novice to expert typically requires years or decades of accumulated experience and study. Advanced prompting techniques don't eliminate this journey, but they dramatically compress certain aspects of it, allowing individuals to produce expert-quality outputs in domains where they possess only basic knowledge. We're seeing a decoupling of production capability from traditional expertise development, explains organizational psychologist Dr. Howard Jensen. A marketing manager with 6 months of experience but skilled in these AI techniques can sometimes produce campaigns that rival those created by professionals with 15 years in the field. This has immediate implications for organizations. The competitive advantage traditionally provided by accumulated expertise becomes less definitive when advanced AI prompting can partially bridge the gap between novice and expert performance. Companies that develop institutional competence in these techniques gain a form of leverage previously unavailable. Winifred Kingsley, CEO of a mid-sized consulting firm, describes the transformation. We've implemented a company-wide program teaching advanced prompting techniques. The productivity gains were expected, but what surprised us was the effect on innovation. Junior team members now regularly contribute insights that previously would have required senior-level perspective. It's democratizing expertise in ways we never anticipated. For professions built around specialized knowledge, law, medicine, engineering, finance, these techniques create both opportunities and challenges. They enable professionals to expand their effective scope of practice by leveraging AI to supplement their specialized knowledge in adjacent domains. Simultaneously, they potentially erode some of the value traditionally attached to specialized expertise by making aspects of that expertise more accessible to non-specialists. Education faces perhaps the most profound disruption. When students can use these techniques to produce essays, solve problems, and generate creative works that exceed their own unaided capabilities, traditional assessment methods become increasingly problematic. The question shifts from, "What do you know?" to, "How effectively can you collaborate with AI to solve problems?" Dr. Raymondson argues that this necessitates a fundamental reimagining of educational goals. We need to move from teaching content to teaching cognition, specifically, the metacognitive skills that enable effective human-AI collaboration. The ability to formulate effective prompts, evaluate AI outputs critically, and guide iterative improvement may be more valuable than many traditional subject matter skills. Several forward-thinking educational institutions are already adapting. The Massachusetts Institute of Technology introduced a course called Augmented Intelligence, the Art and Science of AI Collaboration, in 2023. Stanford's Graduate School of Business now includes advanced prompting techniques in its core curriculum, treating them as fundamental professional skills rather than specialized technical knowledge. Beyond practical implications lie deeper questions about the nature of human creativity and cognition. If someone uses these techniques to create a stunning piece of artwork or develop a novel business strategy, to whom should we attribute the creative act? Is it the human, the AI, or the emergent system created by their interaction? These questions reveal outdated assumptions about creativity, argues Dr. Wendy Kearns. We've romanticized the lone genius model of creation, but creativity has always been relational, influenced by teachers, peers, cultural context, and available tools. Advanced AI prompting just makes this relational aspect more explicit and powerful. This perspective suggests that rather than diminishing human creativity, these techniques may be expanding our understanding of it, revealing creativity as something that exists not solely within individual minds but in the interactions between minds, tools, and environments. For organizations, the strategic implementation of these techniques raises important questions about knowledge management and intellectual property. When employees use advanced prompting to generate valuable insights and outputs, who owns that intellectual capital? How should organizations balance encouraging these productivity-enhancing techniques while maintaining appropriate governance? Companies need to develop clear policies, advises corporate strategist Howard Jeffries. The most successful will be those that create environments where advanced prompting techniques are openly shared, systematically improved, and their outputs thoughtfully integrated into knowledge management systems. Perhaps the most profound implication concerns how we understand the relationship between human and artificial intelligence. Rather than competing forms of intelligence, these techniques reveal them as complementary systems with different strengths and limitations that, when properly integrated, create capabilities exceeding what either could achieve alone. Human intelligence excels at setting meaningful goals, applying ethical judgment, understanding social and emotional contexts, and making intuitive leaps based on limited information. AI excels at processing vast amounts of information, maintaining consistent logical structures, generating variations on themes, and avoiding cognitive biases that plague human reasoning. What we're witnessing is the emergence of a new cognitive ecosystem, explains Dr. Jennings. Just as written language extended human thought beyond the limitations of individual memory, these advanced prompting techniques extend our thinking beyond the limitations of individual cognitive capacity. This perspective suggests that the future belongs not to artificial intelligence alone, nor to unaided human intelligence, but to those who master the art of integrating the two, creating cognitive partnerships that leverage the unique strengths of each while compensating for their respective weaknesses. In a very real sense, we're co-evolving with our technological creations, notes Dr. Hewitt. These techniques are changing how we think, not just what we can produce. The humans who master them develop new cognitive capabilities, ways of structuring problems, evaluating information, and navigating complexity that wouldn't have developed in the absence of these AI collaborations. This co-evolutionary perspective frames these techniques not as cheating, but as a natural extension of humanity's long history of cognitive augmentation through technology. From the invention of writing to the development of mathematics to the creation of computers, humans have consistently extended their intellectual capabilities through technological innovation. The question isn't whether using these techniques is cheating, concludes Dr. Kearns. The question is how we integrate these new capabilities into our understanding of education, expertise, creativity, and knowledge work in ways that enhance human flourishing rather than diminish it. As these techniques diffuse through society, they will likely create new forms of inequality based on access to and mastery of advanced prompting skills. Just as literacy created advantages for those who possessed it during the early stages of its spread, prompting literacy may create significant advantages for early adopters. We need to democratize access to these skills, argues educational policy expert Whitney Kemp. They should be taught as fundamental capabilities in schools alongside reading, writing, and arithmetic. Otherwise, we risk creating new divides between those who can effectively collaborate with AI and those who cannot. As we stand at this pivotal moment in the coevolution of human and artificial intelligence, one thing becomes clear. These 23 techniques are not merely productivity hacks or clever tricks. They represent the early development of a fundamentally new way of thinking, creating, and solving problems, one that may ultimately prove as transformative as the development of written language or mathematical notation. As our exploration of these 23 techniques draws to a close, we return to our opening question. Do these advanced prompting methods constitute a form of cheating, or do they represent something more profound, a genuine evolution in human cognitive capability? The answer emerges not in the techniques themselves, but in what they reveal about the relationship between human and artificial intelligence. These methods show us that the most powerful form of AI is neither a tool that replaces human thinking nor a simple assistant that responds to queries, but a cognitive partner that extends, amplifies, and complements our native intelligence in ways that transform both what we can know and how we come to know it. Howard Jenkins, reflecting on his journey mastering these techniques, puts it this way: "At first, I felt almost guilty about how much these methods enhanced my work, like I was getting credit for something I hadn't fully created myself. But I've come to realize that the ability to effectively collaborate with AI is itself a form of intelligence. The prompts I create, the iterations I guide, the outputs I refine, these all require distinctly human forms of judgment, creativity, and purpose. This perspective reframes our understanding of what constitutes cheating versus legitimate cognitive enhancement. Throughout history, humans have developed technologies that extend our capabilities, from the lever that multiplies physical force to the telescope that extends vision to the calculator that accelerates computation. We don't consider using these tools cheating because we recognize that the human contribution remains essential. Deciding where to apply the lever, where to point the telescope, what calculations matter. Similarly, these advanced prompting techniques don't eliminate the need for human intelligence. They transform how we deploy it. The creativity shifts from generating every detail independently to orchestrating a collaborative process that leverages complementary cognitive strengths. The expertise shifts from memorizing all relevant information to knowing how to access, evaluate, and synthesize knowledge effectively. In many ways, these techniques are teaching us what was uniquely human about cognition all along, reflects Dr. Jennings. As AI handles more information processing and pattern recognition, we discover that our distinctive contributions lie in setting meaningful goals, making value judgments, understanding social and emotional contexts, and integrating knowledge across domains in service of purpose-driven activities. This suggests that rather than diminishing human capability, mastering these techniques may actually deepen certain uniquely human cognitive skills, the ability to ask insightful questions, to recognize meaningful connections between disparate domains, to evaluate outputs against complex human values, and to integrate multiple perspectives into coherent understanding. Whitney Keener, who teaches advanced prompting techniques to graduate students, observes, "My students who become most skilled with these methods don't become intellectually lazy. Quite the opposite. They become more sophisticated thinkers, more aware of their own cognitive processes, and more intentional about how they structure and approach complex problems." Perhaps most profoundly, these techniques reveal intelligence itself not as a property that exists solely within individual minds, but as something that emerges from the interaction between minds, tools, and environments. They point toward a future where the boundary between human and artificial intelligence becomes not a wall but a fertile borderland of collaborative creation. As we stand at the threshold of this new cognitive landscape, we might recall that every transformative intellectual technology, from writing to mathematics to computing, initially raised concerns about diminishing human capability. Yet each ultimately extended what humans could achieve by allowing us to externalize certain cognitive functions while focusing our unique abilities where they matter most. These 23 techniques represent not an endpoint but a beginning, the early development of a fundamentally new way of thinking, creating, and solving problems that integrates human and artificial intelligence into systems of complementary cognition with capabilities exceeding what either could achieve alone. And so we arrive at our essential insight. The true power of advanced AI prompting techniques lies not in replacing human thought but in revealing its highest expression, not in what they allow machines to do for us, but in how they allow us to become more fully human, leveraging our uniquely human capacities for purpose, meaning, ethical judgment, and creative integration in partnership with our increasingly capable technological creations.